All right, now that we did a little review on graphing, let's talk about relations and functions. So we'll start with relations. Simply put, a relation is just a list of ordered pairs. And maybe it represents two quantities, and you're trying to investigate how they're related to each other. And ordered pairs, right, have x and y values. So we call our x values our inputs, and we call our y values our outputs. So just remember that when you plot a point, like let's say 5 comma 7, well, 5 is your x value and 7 is your y value. All right, a relation's domain, that's just all the x values in the relation. So a relation is just a list of points like we have down here. We'll get to that in a second. And all the x values would constitute or make up the domain. Likewise, a relation's range is just all of the y values in a relation. So same thing, just the y values. And a relation is a function if each input maps to only one output. So let's do this example and we'll kind of hit those key points, so kind of illustrate the idea here. So here I have a relation, right? Remember, a relation is just a list of ordered pairs, and each ordered pair has an x value and a y value. So let's write out our domain and range for this relation. So our domain, right, I'm just going to take all of our x values here. So I've got, let's rewrite that. I've got 0, -1, 2, and -5. And usually it's a convention or good practice to write that list from smallest to largest. So we'll go -5, -1, 2, 0, and then 2. All right, so for our range, that's just our y values, which are going to be 0, 4, 1, and -5. Just like the domain, we'll just list those out in order from smallest to largest. So it's going to be -5. -5 is 0, 1, and 4. All right, so we've got our domain and range. And now we want to ask ourselves, well, is this relation a function? And so we said a relation is a function if each input maps to only one output. So I'm going to draw arrows from the domain, from each number in the domain to its corresponding y value in the range, as we've listed at the points here. And I'll do it over here with this one, because we usually write them from smallest to largest. So -5, if -5 is my input, or the x value I'm looking at, which is over here, well, its output is also -5. So I'm going to just draw an arrow from -5 to -5. All right, -1, if that's the x value I'm interested in over here, well, its output, or its corresponding y value, is 4. So I'm going to draw an arrow over here to 4. If my y or x value I'm looking at is 0, well, that maps to 0. So go here and then here. And if we have 2 as our x value, our output is going to be 1. So as you can see here, each input has only one output. If it had multiple outputs, we would have 2 arrows coming out from any given x value. We'll do an example next to illustrate that. But because each input maps to only one output, we have a function, or this this relation is a function. So let's look at one that is not. Okay, same thing here. So let's list out the domain. So we got, for our domain, we have -3, 0, 1, 1 again. But we don't need to write 1 twice. We know that we don't have to list it twice is all. So if you have repeating values for your domain or range, don't write them out multiple times. Just once is enough. So we have -3 again, 0, 1, which happens to appear twice, but we'll write it once, and then 4. And then for our range, switch back to red. Our range is going to be 2, 0, 3, and -2, and 4. Okay, and why don't we write these out in order from smallest to largest. So this will be, what is it, -2, 0, 2, 3, 4. And then for our domain, it's going to be -3, -3, 0, 1, and 4. All right, so now we're just gonna do like we did before, draw arrows from the domain to what value in the range it corresponds with, or can I just draw arrows to create these pairs that we've already listed. So if -3 is my x value, and let's just move this over so it's like nice and right above it like that. So if -3 is my input or my x value, well, my output is a 2. So I'm going to draw an arrow from -3 to 2. If my input is a 0, well, my output is going to be a 0. Like that. And if my input is a 1, well, the output is going to be 3. So draw the arrow there. If my input is 1, my output is going to be -2. So there's something interesting. Here we have the first instance where we have 2 arrows coming from one x value. And then x value of 4 maps to a y value of 4. So this is let's go back up here. This is not a function because of this right here, because we have this x value, it does not map to only one y value. It maps to 2 of them. It maps to -2 and 3. So if we drew a graph and we wanted to plot all of these points listed up here, so we'll just go ahead and do that. So -3, 2 is going to be about here, let's say. 0, 0, origin. 1, 3 is going to be up here. 1, -2 is going to be down here. And 4, 4. 4, 4 will be right there. And let's say we're just, drawing this line going from left to right. And I want to connect the dots. So I'll start over here and I'll connect to this dot. Now, what do? Do we go here or do we go down here? So this is where the problem arises. There's 2 outputs for the input of x equals 1. So this is not a function, and you can't quite graph it like you would, an actual function. So hopefully this makes sense.